All right, here we go. So let's get started. So on Monday, we were here, just to refresh your memory. We went to this, and we had this piecewise function. We graphed that piecewise function on the front of this page that we're working on, and then we took this piecewise function, we started moving it in a lot of different transformations, all right? So that's what we're going back to. So when I graph this here in a minute, that's what I'm making reference to, okay? And so going back to the page that asked you to state. So before we begin, what transformations do you see in this problem? Okay, looks like right what? 4 and horizontal. It's actually a compression, because remember, anything inside the parentheses does what? It says the opposite of my normal thinking. So instead of multiplying by 2, I'm going to divide by 2. So this is a horizontal compression. Yep. Now, I wrote both of these up there, but actually only one of them is correct, one of them is incorrect. All right, we've done this little scenario before. We got to be careful with this. All right. Anytime that we're talking about a right or a left, all right, it's got to be x minus or x plus. In this case, it's not. I got a 2 in front. And so what we have to do first before we do this, remember I gave you this situation. It's like the Play-Doh or whatever, where you take the 2 colors and you smush it all together. I don't really like that. I want to separate the Play-Doh into the 2 different colors. Well, that's what's taking place here. I got to take this 2 out. So I'm going to take the 2 out. It's going to give me x minus 2. Okay? X minus 2. Now, if I were to distribute, it goes back. But I want it this way because it's got my 2 transformations split. Would you still say it's a horizontal compression by 2?
Yeah.
Still got that 2 there. But now it's not right 4, it's what? It's right 2. So that's what gets fixed there. Everybody okay with that? All right. Not okay with it, but do you kind of understand what's going on? It's definitely a little bit different. Okay? All right. Now, I'm going to graph the original function up here, and then we'll talk about it. So you can graph this lightly if you want, but our original function, our piecewise that we graphed, had a parabola there. It had an absolute value graph there. And it had a line here. Okay? So I'm going to take this and I'm going to move this and the different directions that it says that I'm going to do here. Okay? Now, what am I going to do first? I have 2 transformations. I'm going to move the right first. Why? It's inside parentheses. Okay? Think about PEMDAS. What do you do first? I do parentheses, then I do exponents, then I do multiplication division, then I do this subtraction. So I'm going to do the inside of this piece first. So I'm going to move everything right 2. Now, I know that's a little bit easier for me. It's a little bit harder for you, but I'm just going to take and move this right 2. I'm going to take and move that right 2. And I'm going to take this one and move this one right 2. Okay? At some point in time, I think we'll be able to do that. Technology is probably pretty close. You will take your notes on an iPad or something like that. So I have that. I've moved it right 2. Now, the next piece is I'm going to do a horizontal compression by 2. What happens when I do a horizontal compression by 2? I'm going to divide. That is correct. What am I going to divide? The x's. Because it's horizontal, I'm dividing the x's. Okay? So let's take a look. If I go to this one right here, what's the x value there? 0. If I divide that by 2, still 0. So it's still there. All right? If this was another point that we did, a big one there. If I took 1 and I divided it by 2, it's 0.5. If I did 2 and I divided it by 2, it's a half. And if I did this 3 and I divided it by 2, 1.5. So there is the line part of that. So it looks like it got squeezed this way. Now, it looks a little bit funny. It looks like it got tilted this way, correct?
Yeah.
Looks like it pivoted, but it really got squeezed horizontally. This right here is at 4. So if I move it right 2, I'm there. Excuse me, not right 2. If I divide it by 2, I'm at 2. Then 3 gets divided by 2, and it's at 1.5. This 5 gets divided by 2, and it's at 2.5. Now, the parabola definitely looks like it's been squeezed, correct? Question?
No.
So 3 got cut in half, 4 got cut in half, 5 got cut in half. All right? This is 5 right here. It gets cut in half. It's going to be there. That's 6. It gets cut in half. It's 3. 7 cut in half is 3.5. And 8 cut in half is 4. So there is that absolute value part. Okay? So the blue, I shifted the blue to the right. Then I horizontally compressed it. And the red would be my answer up there. Okay? Now, just like every other one that we've done, we came through here, we talked about the domain, and we talked about the range. Okay? What is the domain for the graph, for the new graph? 0 to where? 4. To 4, that's correct. 0 to 4. Now, we've been using interval notation. I can be at 0, but I cannot be at 4, so it gets the parenthesis. You can do the less than and less than or equal to if you'd like. I'm doing that. What happened to my range? Nothing. It stayed the same. That's correct. Why could you say that it stayed the same? What would be a reason that it stayed the same? I'm not doing anything with the y, right? What are the transformations? They're both horizontal, right? Left or right 2 and compression. So only the x is changing. The y is not changing here. So from -3 to 3. Okay? All right. Now, want to connect this. I know it's been a little bit of time. We're going to connect this idea with what we talked about last Friday. So we're using Monday and Friday. We're putting that together. We're looking at this. Okay? Now, this is the one on the right. What is this transformation that we're seeing? Absolute value. All right? Absolute value of f of x. Okay? Now, what did we talk about absolute value? What was the transformation? What did it do to my graphs? It makes it positive. Does it make everything flip? Just makes the negatives flip. And so what we talked about the other day is the positive stays the same and the negative becomes positive. So in this case right here, we're talking about negative y values. The negative y values are going to become positive. Okay? So again, I'm going to start how I've started just about every one of those. Is I'm going to go graph the original. So here is the piecewise that we built on Friday. Excuse me, on Monday, I should say. So there's that graph. That is not correct. I need to shift it up. Let me redo that real quick. My y-intercept is at 1, not at 0. Okay. Now, here we go. So I have this. If you want to lightly draw it, that's not a bad idea. All right? And so if I have this right here, I am now going to draw the absolute value of f of x. And so we said this. The positives stay positive. Positives stay the same. So if I were to do that, the positive. This one is positive. This part is positive. Those two pieces right there, they don't move. They stay exactly the same. Nothing's changing on those. Okay? Now, positive stays positive. The negative becomes positive now. All right? And so this piece right here, this is -2, -3. So -2, -3, the -3 is going to become positive, so it's going to go up here. And so if I connect that, that's what that would look like. Okay? This right here, this -3 right here would become a +3. This -2 would become a +2. This -1 becomes a +1, and I have that graph there. Okay? Now the weird thing about this is some of it looks reflected, correct? But not all of it looks reflected because the positives didn't change. But the red graph that I have there, the red is my answer. That's my correct answer. Okay? Everybody okay with that? So real quickly, what I'd like for you to do, I want you to tell me the domain and the range for the red. Okay? All right. Somebody got the domain for me? -2 to +6. Good. All right. Was that the same as the first one that we did? Does that match the original? It does. That didn't change. Okay. How about the range? Say again. It's the red. Don't graph the purple. So 0 to 3. 0 to 3. Now, does 3 get a parenthesis or a bracket? Am I equal to 3? All I have to do is be equal to it once, and I'm good. This one right here, when I flip this up and flip that one up, they were both +3. They became 3. I know we're not at 3 on this piece, but we are 3 there, so we would put a bracket. We'd have a bracket for both. Okay? Now, what's true about the range if I were to match it up here? How do I know my range is correct? Or what would be a good check? Say again? It's not negative. I don't have any negative numbers, correct? So I know if I'm taking the absolute value of this, right, all my y's should be positive, which that kind of confirms that. Good? All right. Let's take a look at the one on the bottom left now. How is this one different? Just the x. We're only doing the absolute value of the x. Not the whole problem. Just the absolute value of the x's. So the way that I'd probably state this is the positive x's are going to stay positive. The negative x's are going to look like the positive one. So the positive x's are going to stay positive. They're going to remain. The negative x's are going to look like the positive x's. Okay? Again, I'm going to draw this again. Okay? So here is my parabola. Here is my absolute value. And here is that line. Okay? So there's my original function. Now, if I'm going to take the absolute value of positive x's, what's going to happen with all the positive x's? They're going to stay the same. Where are my positive x's on this graph? On the right. Past the y-axis on the right. So this is going to stay the same. This is going to stay the same. This is going to stay the same. Okay? Everybody okay with that? All right? Now, what does a negative x, what is it gonna do? For instance, this one right here, this is -1, correct? But if you put a -1 in there, it's gonna be +1. And what's +1 gonna do? +1 says I should look like this right here. +1 says I should have a open circle there and a closed circle here. That's what's happening at +1. -2. -2 is going to look like +2. So it's going to have this there and this there. So what does it look like I've done to the graph? Looks like I've reflected over the y-axis, right? Now, why didn't I draw more? So it's like incomplete, right? I'm going to draw more of this, right? Why wouldn't I draw more of that? Any thoughts?
Why is there that random line right there?
Which random line?
The blue one.
The blue one right here?
Yes.
That's the same as this one.
Wait, but why is it reflected? Wouldn't that x be negative?
Huh?
Wouldn't the x be negative now? If the green looks
Well, only the x is negative. So if I did this, -2, all right? So -2, if I plug that in, it's gonna act like a +2. Well, what's +2 saying? +2 saying be at that point right there. So I put -2 in, but I got +2. +2 is 0, so it's there. You can put all these other little numbers in between here, like all the numbers between 1 and 2, but it's gonna look just like that one right there. I reflected it over that axis there, okay? Now, I didn't reflect the whole thing. Why not? Well, the reason I did not goes all the way back to the very beginning. What's our domain? -2 to 6, correct? So do you have a -3 to reflect? You don't have it. It stops at -2, correct? So I don't have a -2. I can't really reflect it. So I don't have anything to put in. So that's why I would stop this here. That's why I wouldn't go all the way and graph the whole piece. Okay? So the right side stayed the same. The left side, it's reflected. What it looks like. Okay? So I'm getting, it's like the negatives went away. The negatives went away. It's acting like the positives on the right side. So the negatives are going to reflect the positives. Okay? All right. We're going to do another example of it here in a second. I'm going to do one more here, and then we'll go. All right? Okay? Now, that's not us. All right. Here we go. I want you to write me the transformations here. Very last one on the page. Write me those transformations. All right. What transformations do you see on this one? Okay, we're going to do absolute value of x. What's the negative going to do? Okay. What transformation is that? It's a horizontal reflection. Okay? So that negative in there is a horizontal reflection. Okay? So let's take a look. If I were to graph the original, so the original piecewise function that we started with, there, and here. Okay? Now, did we do this transformation already on this page? Horizontal reflection? We did, right? It was a couple above. We did it on Monday. And so if I do a horizontal reflection all the positives become negatives, all the negatives become positive. We're just flipping sides. Okay? So if I were to do this, this piece would go here, the parabola would go here, this piece would go over here. So I'm flipping everything side to side. So the blue would be my horizontal reflection. Okay? Now, that's what some of you wanted to do in that last one. You wanted to flip the whole thing. All right? Now, on this one, this is where it's kind of a little bit weird. All right? We did the reflection. Now let's apply the absolute value. What do we say about absolute value? This side right here stays the same. The positives stay the same. The negatives, they basically go away. The negatives look just like the positive side flipped. So we take this, and we would have that right there, and that purple would be our graph.
Only the purple would be?
Only the purple would be the graph. Okay? It's weird. It's a little bit different. Okay? We flip the red, all right? Then we're only graphing the positive part. And then the negative part's going to be a reflection of the positive part. So I'd have that there. Okay? That's a really weird one. I don't know that you'll get a lot of those. All right? Just trying to kind of pull all that together. Now, let's do a little bit more. All right? Let's do another little function. Okay? So, on that one, on that little worksheet, we blended the piecewise and we blended absolute value, and that looked together. All right? So, I want you to take a look at the worksheet that you picked up on the way in. Looks like this. All right. Now, a couple little things here. All right. So I've given you this wave-like shape of a graph. We're going to say that that's f of x. Okay? So the first thing I'd like for you to do is I want you to go find me the second column. Go find f of x. Well, I'm going to use my graph to do that. If I were to do -4, where's -4 on my graph? Right there. The y value, that is 0. So that gives me 0. So go fill in the rest of the table.
Darn it.
I know you're hungry.
We don't get to jump. Oh my God. Oh my gosh.
Not that complicated. Alright, you're finding the y values. Me, you're done. A couple of you. Still working on that.
So which part should I highlight that we keep? Like, I highlighted the part that we kept. What?
Alright. Here we go. Let's fill in now. Alright? So on this, for -3, what did you get? 1. For -2?
Negative
-1. Alright, here we go.
And zero.
Here's the next thing I need you to do. Okay? The second column. What does the second column state? Absolute value of the y. Absolute value of f of x. So on this column right here, I'm going to do the absolute value of that column right there. Okay? So that ought to be pretty easy to fill in. Okay? So go fill that table in. Absolute value of the first column that you filled in. So go fill in those answers. Absolute value of that first.
I don't care, it's just eight.
Alright, here we go. We got a lot of little side distractions. Alright. What should be true about everything in the second column? Should all be positive. 0 or positive. So this is 0, 1, 0, 1. Very unique table. Alright. Now, here's the last thing I need you to do before we head to lunch. Alright. What I'd like for you to do is this. I want you to graph me this x versus that column. So take these points, the -4 to the +4, and use this value of y with it and go graph those on your graph. So graph your x's with your absolute value of f of x. Go put them on your graph.